Hello everyone, and welcome to today's product training session. I'm thrilled to have you all here and look forward to spending this time together. I hope today's training will provide you with valuable knowledge and skills to better understand and use our product. If you have any questions during the session, please feel free to ask in the chat. Thank you once again for being here. So now, let's start with the introduction of X-ray machine. The X-ray machine is an indispensable piece of equipment in modern medicine. It uses high-energy X-rays to visualize human tissue, providing doctors with internal images that cannot be seen with the naked eye. This assists in diagnosing and treating various common diseases and pain symptoms. X-ray machines are widely used to diagnose conditions such as fractures, lung infections, tumors, and kidney stones. Under X-ray radiation, the internal structure of the human body is clearly displayed in images, providing doctors with a basis for in-depth study to customize the best treatment plan for patients. Beyond medical applications, X-ray machines played a crucial role in security checks, scanning luggage, mail, and other items to quickly and accurately detect hidden dangerous or prohibited items, thus ensuring public safety. Due to the high-energy nature of X-rays, safety is paramount when using X-ray machines. Operators must undergo specialized training to avoid radiation harm during use. Patients should also use or wear appropriate protective equipment during X-ray examinations to minimize radiation exposure. It's time to move on to the features and advantages of our X-ray machine. The popular model is MY-D023G. Let's start from the mechanical structure feature first. It has the dual column design, which allows for complete body imaging without blind spots, and also facilitate examinations. The integrated bed and X-ray tube columns allow for quickly installation and reduced room space. The diversified flat panel detector chase structure supports 80% of the market's detector manufacturers, offering customization options for clients. The linked design between the flat panel detector tray and tube column simplifies operation for doctors. It's time to move on to the features and advantages of our X-ray machine. The popular model is MY-D023G. Let's start from the mechanical structure feature first. It has the dual column design, which allows for complete body imaging without blind spots, and also facilitate examinations. The integrated bed and X-ray tube columns allow for quickly installation and reduced room space. The diversified flat panel detector chase structure supports 80% of the market's detector manufacturers, offering customization options for clients. The linked design between the flat panel detector tray and tube column simplifies operation for doctors. The second part is an X-ray tube. This machine is equipped with branded tubes from a 30-year-old company, ensuring quality and durability at the same time. The high heat capacity design can support the continuous operation. The 0.6 and 1.2 microfocal tubes can produce high-quality images. The voltage range is adjustable from 40 kV to 150 kV, which meets the needs of all body parts. The third and fourth are about the flat panel detector and the software. The transmission speed of the flat panel detector is up to 1300 Mbps, which allows the images to be produced within 3 seconds, a very fast speed. It has a high resolution for an image quality, so I think the doctors will appreciate it. It also has a highly sensitive AD function, can help easily connect and sync with any high voltage generator. The software includes many functions, including AED automatic exposure, one-click calibration, film printing, diagnosis, report printing, a lot of modules included. The software was designed with the latest algorithms and technology, so it is good for seamless full spine imaging, for example, ensuring uniform grayscale and image integrity. This video is a brief overview about our X-ray machine, MY-D023G. From this video, you will see how it looks like and how it is used. voltage generator has a 500 kHz inverter frequency with low ripple and minimal scatter, providing stable and high-quality X-rays. The high-power X-rays in this system can meet the imaging needs for various body types in real hospitals. The quality of X-ray tube is also a very important thing to consider when choosing X-ray machines. Our X-ray tube has a large heat capacity, so it can support high throughput and continuous imaging. The built-in dual focus is also vital for the X-ray tube. The flat panel detector used in this imaging system is made of calcium iodide, so it obtained high sensitivity, high DQE, and clear imaging. This flat panel detector is quite large. It is 17 inch times 17 inch. So it's good for a large imaging area, and you can get richer details. From the video, we all learn more about an X-ray machine. So here I will continue to introduce the parts in this high-quality imaging system. In this slide, I listed every component in our X-ray imaging system. Just have a look at the left side. You can see the chest stand there. The main part is the column. The flat panel detector box is the square at the middle. It has a positioning handle at the back, so it can go up and down on the column. The middle one, which is also the heaviest part of the X-ray machine, is the flat bed. You can see a column also. On the column, you can see the head. The head consists of the X-ray tube, the collimator, and a control panel. The bed is where the patients sleep and take images. The flat panel detector box is under the bed. You can see a pedal at the bottom of the machine. It works like the switch. If you don't touch it, the bed is locked. But if you stepped on it, the bed can be adjusted to acquire the best image. On the right side of the slide, you can see the flat panel detector. It should be put in the flat panel detector box, either under the bed or on the chest stand. The flat panel detector works together with the imaging software, which should be installed on your computer. The white cube at the bottom right of the slide is the high voltage generator. It powers an X-ray tube. The high voltage generator is vital in the system because it generates high energy electrons for the X-ray tube. The high voltage transformer is a key component, raising the input voltage to the required level for X-ray generation. Another essential component is the filament transformer, heating the filament in the X-ray tube necessary for generating high energy radiation. The high voltage rectifier converts high voltage to AC to DC, producing high voltage DC for X-ray generation. The transformer box protects the generator's components. The high voltage sockets connects the load to the generator, ensuring efficient high voltage transmission. In this video, you can see KB, MA, MAS, and MS can be set in this control panel. The second part is an X-ray tube. The X-ray tube generally consists of the core, tube housing, radiator, insulating oil, etc. The core, comprising the anode and cathode, is the most crucial part. The power of the medical X-ray machine refers to the power of the X-ray tube. Generally, higher power results in a greater penetration depth, shorter exposure time, higher image quality, and the ability to examine more body parts. The next one is the flat panel detector, also short for FPD. They are crucial components in digital radiography systems, which is also called the DR system. They convert X-ray energy into electrical signals for image formation. These detectors can be characterized based on the energy conversion methods. There are two types. One is indirect conversion, and then the other one is the direct conversion. The materials used in flat panel detectors include cesium iodide, amorphous selenium, and CCD. In the indirect FPDs, X-rays are first converted to visible light using a scintillator material. This visible light is then converted to electrical signals by photodiodes. Finally, these analog electrical signals are digitalized by an analog to digital converter. The cesium iodide is used in this kind of detector. In the direct FPDs, the photoconductive semiconductor converts X-ray photons directly into electrical charges. These charges are read out and digitalized using a thin film transistor array. Amorphous selenium is used in this kind of detector. As for the CCD type, an intensifying screen is used as an X-ray interaction medium, and a CCD is added to digitalize an X-ray image. It also used the cesium iodide. My medical includes the cesium iodide type flat panel detector in our imaging system. You can choose the wired type and wireless type based on your need. This video shows the flat panel detector and its box, where it should be placed. The next one is a common radiation control device. It is called the X-ray grid. It is used to reduce radiation doses to the human body and equipment during radiation detection and treatment. It primarily absorbs and filters high-energy X-ray radiation, preventing harm to the body and reducing artifacts in the items being examined. X-ray grids are similar in appearance to regular grids, and they're composed of parallel lead lines. These lead lines are typically arranged in a regular grid pattern or parallel plates. The thickness and spacing of the lead lines are determined based on the application scenario and the type of detection or treatment equipment. Proper parameter design ensures detection or treatment accuracy while minimizing radiation doses to the human body and X-ray tube. The pictures in this slide show you where the X-ray grip is placed in the X-ray machine. The cube at the bottom of this picture is called collimator. It controls the X-ray beam range and radiation dose. There are many types of collimators. For example, manual, automatic, and fully automatic. Some electric collimators can be controlled by feedback or dose, X-ray dose. Take the collimator we used in our product as an example. First, it has an integrated manual and electric design. Second, it has a user-friendly door handles for single-handed operation. Third, a large touchscreen interface, which is good for simple and intuitive operation. Fourth, the real-time display for position data. Fifth, the real-time communication with the workstation, which is the computer. This video is about how to use the collimator. Okay, let's move to the chest stand. You can see the flat panel detector box, so it is where you take the chest film. The holders can install an X-ray grid inside to enhance imaging quality and clarity. This video is about how to use the chest film column. This part is the machine bed. The floating bed surface is controlled by the electromagnetic braking inside the machine. The bed facilitates positioning patient body parts. It works for ascending, lying, and lateral imaging of the head, chest, abdomen, limbs, and bones of patients. From this video, we will learn how the bed is used. In this slide, you can see the image acquisition and processing software, and also the workstation. The software has a user-friendly interface, so it's very easy to operate. Because there are many types of patients, you can choose optional patient body types. For example, obese adult, normal adult, thin adult, and child. The software is available to use dual detector. It's easy to switch between the standing position and lying position. The software also supports remote reading of images. These two videos will show you how to take X-ray images with our X-ray imaging system. X-ray machines have been sold to many parts of Africa. These are the real images taken in the Nigerian hospital. I understand that many people will focus on the configuration of our X-ray machine, so I wrote the most important parameters in this slide. First, you can see the X-ray tube, the voltage, the microfocus, the heat capacity, the rotating speed, the X-ray coverage, and the surface life. There are many types of high voltage generator, so I will only take the 65 kilowatt one as an example. So you can see it is three-phased, working under 380 volt AC, the working frequency, the volt range, the current range, and also the exposure time range. I also wrote many parameters of the detector here. It's 46 times 46 centimeters in size, but it is very light, only 3.7 kilogram. Just enjoy your time reading the configurations, since I have already listed the most important things here, including the data transfer speed, the scintillator type, pixel matrix, pixel pitch, spatial resolution, image size, minimum detectable dose, maximum linear dose, AD conversion, and the X-ray voltage range. The pattern column are easy to install and easy to operate, so don't worry about that. We will also deliver a lecture about installation later. There's a criteria about the X-ray room. The size should be 4 meters in width, 6 meters in length, and 3.5 meters in height. As you can see in the picture, I put an easy map here so you can figure out how the room is supposed to be designed and where the machines are supposed to be placed. Thank you all very much for your attention. I hope today's presentation has been insightful for you. If you have any questions or would like to discuss further, please feel free to reach out to me. We also look forward to your participation in our upcoming events. Once again, thank you for being here and have a wonderful day. Thank you so much.